let's take a look at how we can find the maximum or minimum value of a quadratic function. As a reminder, a quadratic function has its graph as a parabola pointing up like this when the quadratic coefficient is a positive value. And so consequently, when the parabola is pointing up like that, that cup shape is pointing up, then the vertex of the parabola becomes a minimum. And so now in this type of problem, I am going to refer to the vertex as the minimum, the lowest point on the graph. And in other case, the quadratic we are looking at is going to have the graph as a parabola pointing down like this when the quadratic term has coefficient negative. And so in that case, the vertex will become the maximum value. Or in short, to say the maximum. And so before we really advance to the actual problem, then one rule of thumb we can always keep, but anytime we are working to find maximum or minimum value on a quadratic function, then you can keep in mind this one rule of thumb that any quadratic function, or in short people just call quadratic. So any quadratic function can only have either a maximum or a minimum value. But can only have either one of the other. And so we can never have a quadratic that has both maximum value and minimum value that happens at the same time. All right, so let's look into our first example in finding maximum or minimum value of a quadratic. So in our example 1, let's say we are given a function. How about I'm gonna name our function here p of x, and being negative 0.06 x squared plus 84x. And so right here in this problem, in this function right here, before I write down the actual question of the function, because we're only having the function given, but immediately recognize for yourself that this function here is being a quadratic, and quadratic coefficient is being negative 0.06, and the linear coefficient is positive 84. But immediately finding out that the quadratic coefficient is being a negative value, then we should have now some expectation in mind that this quadratic must have a graph appears to be a parabola pointing down, and the vertex here would have to be this vertex here would have to be the vertex, but it must be the maximum value, the maximum. And so that's some expectation we have in mind already. So what we just now need to really tear it down to details that graphically speaking, how high is the value? That means the y coordinates, the y value equals how high up, and what's the x value here that gives us, what's the x value on the x-axis that gives us the parabola hits the maximum height right here. And so here's how the question is going to start being addressed here. Here I'm going to start my first question. The question now is asking at which x value is p of x maximized. And so in this way that the question is being worded, refer back to this quick sketch, this illustrative sketch right here that I have. But basically we want to find out, the first thing is that where on this x-axis, or which x value is going to be responsible for the function coming out with the highest y value. So the highest y value here has to happen corresponding to some x value on the x-axis, and that's what we're finding out. So find out right now we're finding, and in other words, we're looking for the x coordinates of the vertex point. And so now we have learned that the vertex point has the x coordinates being found by the formula minus b over 2a. A lot of explanations from me, but in the end it brings down to just that simple step right there. So x coordinates of your vertex point, or now in this context right here, the maximum value of the maximum is going to be just minus b over 2a. And so all we do now is simply to substitute in the value b and a that we have already addressed before we even started the question. And so substituting in the value of b and a that we have previously addressed, then the formula here is going to become minus 84 substituted in for b divided by 2 times a, but a is now substituted by negative 0.06. So negative 0.06. And so now calculation comes out to be positive 700. And so now that we found the function p of x will reach its maximum y value, or maximum output value, when x equals 700. And so making our final conclusion, we can just simply say in a formal statement, p of x is maximized at the value x equals 700. So there's our final statement there regarding the x value of the function p of x, where it hits the maximum. And then before I'm moving into the next question, you can notice that by the end of this question right here, we found the answer. We did not provide the answer to, we did not find out, in other words, that's what I was trying to say, but we did not find out how high this function reached when x equals 700. We did not answer about which y value, how high is your p of x, how high can your p of x value reach when x equals 700. And that is the whole reason for the next question to come. And so for question B now, we would like to find the maximum value of p of x. And so this way of how I'm wording the problem, quite standard, but actually brings up immediately that intention about we need to find how high of the y value of your function can reach when x equals, because keep in mind after part A we already found the function will reach to the height, the maximum height when x equals 700, but we did not answer how high that y value was. And so here we have to find the maximum value, and I need to underline that, you see, value of f of x, value of p of x refer to the height, and so we want to find the maximum value. So that meaning again, we want to find the highest y value that will happen to the function p of x when x equals 700. And so now just remind yourself once again that maximum or minimum is just another name of the vertex point. And so we have learned that after we found x equals 700 is where we're going to reach, your function p of x reach the maximum or reach a vertex point, then the y value here now comes out simply just a matter of substituting in 700 into your function p of x. So 700 substituted in, and so now calculation is going to come out negative 0.06 multiplied with, in parentheses, 700 squared plus 84 times 700. And final calculation here comes out being 29,400. And so, final conclusion. This is the answer in short, but final conclusion, we're going to say maximum value of p of x equals 29,400. Now let's look at another example of finding maximum or minimum value of a quadratic function. So here, let's say we are given, and I would like to name my function a little bit differently. So how about q of x here, capital Q of x equals, and what I have here, 0.04 x squared plus 0.3 x minus 6. And so before I write down the question, then again we can immediately look at the quadratic coefficient being positive 0.04. This quadratic of yours here also has a linear coefficient being positive 0.3 and the constant term being negative 6. But immediately looking at the quadratic coefficient, which is a positive value, then before even look at the question, we can already have an expectation that our parabola for this function must be a pointing up cup like this, where the vertex of the parabola now appears to be so this is where the vertex, and it must be in this context right here, since a is positive, then your parabola is pointing up, and so the vertex now would become the minimum. It's just the way it is of the graph and the way it is for your quadratic function. And so now in that way, once again, we just need to find out. So question A here I'm going to bring up, at which value of x is this function q of x, but this time I'm going to say minimized. All right, and so once again, similar explanations that I can be presenting here, but so minimized here refer to that the y value of the output value of your q of x function must be at its lowest value. And so we want to find out which value of x on the x-axis here, which value of x responsible for having the output value of q of x being at its lowest, at its minimum. And that's what it means by at which value of x is q of x minimized, in a short and precise way of saying that. But then in the end, being a minimum like in this problem or being a maximum like in the earlier example, they are just different names of saying we have a vertex right here. And so to find the x value of the vertex, once again, all we do is set up that formula x equals, and so now minus b over 2a. And so minus, your b value was recognized previously to be 0.3. So I'm substituting that into my b variable of the formula, and divide it by 2 in parentheses positive 0.04, which in turn calculation comes out to be negative 3.75. And so, of course, I mean negative here, but does look a little bit inconsistent with my picture that I'm drawing here, because it seems like in a way how I placed my parabola, it was more like on the positive side of the x-axis. But it's okay. Here I'm only representing the idea of that. But then, so now x equals negative 3.75 is where we hit is where the function hits the minimum value. And so we're now going to make our final conclusion. So simply stating x equals negative 375 is one way, or we can say that a little more formally, q of x is minimized at x equals negative 3.75. And that is our answer to the question. And now once again, question A we answered earlier did not answer how low our value of the function q can hit. And so here we're going to try to find out that answer over here. So we want to find the minimum value of q of x. And so I need to underline again, but the value of q of x, graphically speaking, is the y value. So the y value here, the y value of that vertex right there is the output value of q of x. But now we look for, and you can see that it's the shortest height out of all right there. So that's why it's the minimum. We're looking for the minimum value of q of x. But so after we already found the x value from question A previously, x was found to be negative 3.75, and remind yourself that this is where your minimum height was reached right there. But that was only at where that was. So now to find the y value, q, in parentheses, we're substituting in negative 3.75 into the function. So once again, just once you found the x coordinates of your vertex, simply just substitute that into your quadratic function, and then it will give you either the maximum that we were looking for, or now in this case right here, the minimum that we are looking for, the minimum value that we're looking for. And so let me lay down one calculation step for here, but positive 0.04 as the quadratic coefficient times a negative 3.75 in parentheses square plus 0.3 times negative 3.75 minus 6. And so now final calculation comes out being negative 6 into decimals, or maybe I can just go with the complete precision, negative 6.5625. And that's all for the answer. So we found y equals negative 6.5625. But in this context, we're saying that the minimum value of q of x is negative 6.5625.